Hey y'all, hope y'all are doing good and hope that you had a good first day back with notes from spring break. I know they were a little bit long and I'm sorry that it ended up being 51 minutes. But I don't know how long they're going to be because I don't normally teach this way. Y'all know I like to have my worksheets and I like to just have spots where you fill stuff in. So they're a little bit longer than they normally are because we have to sit here and write everything out. We did a Zoom call with Mr. Robertson today and it went well. And he just wanted us to check in with y'all and make sure that you were doing okay and you didn't need anything. If you are having issues with internet or you're having issues with computer access or anything like that and need some help from me or need some help from administrators or some resources from the school, you can just reach out to me and I'll make sure to relay that message if I need to. And he just kind of wanted us to do a little mental health check and make sure that all of our students are healthy and safe and as happy as they can be right now with the given circumstances. So again, if y'all need anything, please reach out. You can always message me on Remind or send me an email, and I'll be glad to help out as best I can. And if you are behind on assignments or you maybe didn't do one, it's okay. All right, just go back and do it. I'm not penalizing you for turning it in late. I don't think that's fair and equitable given the pandemic. But I really do want you to do it and do the best that you can. But I also don't want you to feel stressed and feel like you're overwhelmed with the amount of material. So just giving y'all a heads up on that. If you need anything, please let me know. And I'll be glad to help out as best I can. Now, today's notes are going to be the pathway of circulation, and it's a little bit out of order because I'm used to having the diagrams done first. So we're going to have to do a little bit of back and forth and thinking about it from a picture and then thinking about it from a flow chart. So first thing I want to do is think about the heart, and I'm going to get my picture out from yesterday, but the image that we drew was this picture of the heart. Did we lose it? Come on, buddy. All right, there we go. Is this image here. And remember, the heart, or the mammalian heart that we're looking at, has 4 chambers. And those 4 chambers are the superior chambers, which are called atria, individually, right atrium and left atrium. And then inferior is going to be the right and left ventricle. Now, there has to be unidirectional blood flow through the heart, meaning that blood has to come in through the atria and out through the ventricles. And that movement of blood is controlled by valves. And the way that I think about valves are doors. The door is open or the door is shut. And when the door is open, blood can flow through. When the door is shut, it cannot. Okay, and it can almost prevent you from leaving a room, just like it can prevent blood from moving in the wrong direction. And those valves are going to be situated either between the atrium and the ventricle on either side, or they're going to be situated about right here. Okay, and it's hard to draw it in 3D, but there will be another valve with a different shape, therefore I drew it as a circle here, that will allow blood flow to leave the ventricle and go out to the lungs from the right side of the heart, and then leave the left ventricle and go out to the body from the left side. So these doors will ensure that you have unidirectional blood flow. When the door is shut, okay, let's pretend like this valve is shut. Blood can't go from the ventricle back up into the atrium. It cannot backwash up into the atrium. Same thing would be true here. If this door is shut, then blood cannot go from the ventricle to the atrium. So these doors will swing open and swing shut depending on the force on either side of them. And the same thing would be true on these two valves. These valves are going to shut, and they're going to allow blood to go out a blood vessel and to the lungs. And when they, I don't know if I said that right, if these valves are open, they will allow blood to go out to the lungs. And when they are shut, they prevent blood from going back down into the ventricle, okay, on either side. So these valves are different in shape, and they have different names. So we're going to do another little flow chart, really similar to what we did right here on the chambers of the heart, and just talk about heart valves generally. Okay, so heart valves come in two forms. They are either atrioventricular, okay, atrioventricular, shortened to AV, or they are semilunar. Okay, so let's do our favorite thing and split the word up into its stems and figure out what they mean. Okay, if it is atrioventricular, knowing what we know about the heart so far, it would probably mean that it has something to do with the atrium and the ventricle. So which valve that we drew in would be between the atrium and the ventricle? These. Okay, these are your two atrioventricular valves that are AV valves. The other two are semilunar. Okay, semilunar because they are shaped like half moons. Semi means half, lunar means moon. Okay, now we're going to split these up again. Atrioventricular valves, generally speaking, we can define them, are found between the atria and ventricles. So that's the anatomy definition. The physiological definition would be, well, what do? Okay, they will prevent the backflow of blood into the atria when the ventricles contract. Okay, they prevent the backwash, the backflow of blood into the atria, right or left, when the ventricles, right or left, contract. Okay, so let's look at my little, I don't break it. Let's look at my little heart here. If I flip it over, you can see the internal structures. Okay, I love this little thing because it's tiny and I can teach from it and carry it around. But here's our right atrium and left atrium. Here is my valve that's found between them. The valves are atrioventricular because they are between the atrium and the ventricle. And when they close, okay, they are pushed close, if I could smush it shut, they will prevent the backflow of blood into the atrium when the ventricles contract. So imagine me squeezing these ventricles as hard as I can, contracting that muscle. That's going to put force upwards. That's going to squeeze. And therefore, you have to have a good door to shut off this atrium because, again, we don't want blood going back into the atrium. We want it to come into the atria and down into the ventricles and then out to the lungs or to the body. So if we have a door there, an AV valve, that will close when the ventricles contract, we're good because there is this seal, for a better term, that will prevent that backflow. Okay, now, there are two types of AV valves. whether we're on the right side of the heart or the left side of the heart. On the right side of the heart, it's called a tricuspid valve. On the left side of the heart, it is called the mitral valve, or sometimes called the bicuspid valve. Every doctor is going to call it the mitral valve. Okay, but because this is cuspid, there is also a cuspid name for it, which is either tricuspid on the right or bicuspid on the left. What does cuspid mean? A cusp is a little cup. And on the right side of the heart, there are 3 of them. And I have created just a little image of this valve. There are 3 cups that will hold, let me say that again. There are 3 cups that will kind of cinch together and prevent the backflow of blood into the atrium when that ventricle contracts. On the left, there are only 2. So it is called bicuspid. Okay, now again, we're going to use mitral because that's what you'll see everywhere in the world, but bicuspid is also an interchangeable term with that. So these little cups are your cusp, and they are anchored by little bitty strings. They are called heartstrings, and we'll look at them again on Friday, but these are called chordae tendineae. Tender cords that hold and anchor this cusp down into the ventricle wall. So this right here, MV, stands for mitral valves on the left side of the heart, 2 cusp, and these little stringies would come down and attach down into the ventricle wall, and that's how that valve is anchored. Now, semilunar is a little bit different. Okay, they are not controlling blood flow from the atrium into the ventricle and then preventing that backflow. They are going to be found, how do I want to say this? They are found, or they control, I should say, let's do physiology first. They control the blood flow into the aorta and pulmonary trunk. We're going to look at that again in a second. Okay, so they're found on the entrance of the aorta and the pulmonary trunk. So long story short, and I'm trying to do this without having our diagram done yet, but long story short, we're going to have blood that obviously comes through this right atrium, now through the right AV valve, which is called the tricuspid valve, and that blood is going to flow out into a blood vessel. There has to be a door that controls that blood flow into that blood vessel. The name for the vessel is the pulmonary trunk. The door that will open or close to allow that blood flow or not, and to prevent the backwash, is a semilunar valve. And you have 2 of them controlling the exit of blood out of the ventricle and into 2 very important blood vessels. Okay, so the structure of them is semilunar, and they are going to appear like half moons, and they are different depending on the right and the left again. Okay, the right semilunar valve is going to be called your pulmonic or pulmonary valve. And your left is called the aortic valve because it is going into the aorta. And they have a kind of a Mercedes sign appearance to them. If they're round, they do not have the little stringies, they do not have the little cusp. Both of them have the same shape. And it's almost like you take 3 half moons, like so. Okay, so this is half moon 1, 2, and 3. And they will seal off in the center if it's drawn perfectly and is the actual valve. And will allow blood flow to go into the aorta or the pulmonary trunk, and they will prevent backflow into the ventricles. Okay, so they really prevent this backwards blood flow back into the ventricles. Okay, remember we wanted to go in and out smoothly. We don't want any backwash of blood into the ventricle, because by the time that valve closes, we are refilling the heart. And if we were refilling here and backwashing here, we would overfill the heart. And so there has to be this perfect synchrony of an opening and a closing of either the AV valve or the semilunar valve, and back and forth. Okay, I think I'm cool with this. Don't think we need to do anything else. I do want to touch on one thing about blood vessels before we get into the pathway of circulation flow chart. Okay, now blood vessels will have their own day next week sometime. But right now, let's just talk about the different types of blood vessels. Okay, long story short, there are 2 main categories for blood vessels. They are either arteries or veins. And we've talked about arterioles before, we've talked about venules before, we've talked about capillary loops before. And that artery and vein are going to carry deoxygenated blood or oxygenated blood, generally speaking. And they're also going to carry blood in different directions. Arteries will carry blood away from the heart. Okay, and 9 times out of 10, that blood will be oxygenated. There's one exception in the body, which we'll talk about when we do our flow chart. Okay, artery starts with A, so does away. Arteries are carrying blood that is oxygenated away from the heart to my body, up to my neck and head, down to my belly and my toes. Okay, this is what I'm talking about with arteries. Yesterday I said it goes out to the lungs or out to the body. That would be done with an artery because we're going away from the heart. We're either going right here to my lungs or we're going everywhere in the body, the systemic side of things. Veins, on the other hand, are going to carry blood towards the heart. And again, 9 times out of 10, that blood is deoxygenated. Okay, it does not contain oxygen. Why? Because I've got to get blood back to the heart so that it can pump it to the lungs to get oxygen again. Okay, so all that oxygen has been used and it's draining back through veins to the heart so I can send it to the lungs to get more oxygen. Okay, it's all about this give and take of oxygen in either side of the heart, whether we're pumping that oxygenated blood away or pumping the deoxygenated blood away to the lungs to pick up our oxygen snack. Okay, you're going to need 3 colors. I'm using red, blue, and green. I definitely recommend red and blue, and the green is just going to label different types of circulation, so you could use pencil for that. You're going to need another piece of paper, and we are going to turn it sideways. Okay, so you'll be doing your notes the next set of notes this direction. And I'll give you a second to grab your red and blue. And again, if you want to use green, you can, or you can use pencil. I'm going to save this part of the video just in case we run into the same issue that happened last night. And I'll see you in a second. So go get your colors and get one more piece of paper. Okay, so the second part of the notes is going to be the pathway of circulation through the body, to the lungs, and then to the actual heart itself. So this is what we're going to end up with. You want to kind of plan ahead a little bit. You want to write small, but we're going to fill up the whole page, so you don't have to write super tiny. And we're going to draw these little bubbles underneath or beside certain parts that we will, actually no, we're not going to do it that way. We're going to write it in the colored pens that I told you about. So keep that red, keep that blue. And we're going to talk about the pathway of circulation again from the right side of the heart to the lungs, back to the left side of the heart, and then to the body. I'm going to start right here. Okay, I like to start with the right atrium. It's just kind of how my brain works. And we're going to work our way around and back to that right atrium. Okay, so before we get started with that, let me get my pens ready. You are going to need your blue pen, okay? And remember, blue is going to designate your deoxygenated blood, even though we know that it's always red. Okay, maybe a bit more crimson or darker red. We'll go garnet for Gamecocks, but that coloration might be slightly different, but still red. All right, so we're going to start with the right atrium. I'm going to put my right atrium about right here. And blood enters that right atrium that is deoxygenated. And there are going to be 3 blood vessels that will deliver blood to that right atrium or bring deoxygenated blood into that right atrium. And the first 2 are the superior vena cava. The second one is the inferior vena cava. And the third one I'm going to wait on. Okay, so the superior and the inferior vena cava are all going to deliver deoxygenated blood into the right atrium. And then you have to ask yourself, well, is this an artery or a vein? Then you think, well, number 1 is deoxygenated blood, so that already checks the vein box. And we are going towards the heart. I'm going towards the right atrium. If I'm going towards the heart, we learned just a few minutes ago that veins always carry blood towards the heart. So both the superior and the inferior vena cava are veins, and they are going to deliver blood to the right atrium. That right atrium is going to send blood through the tricuspid valve. We go through the tricuspid valve and into the right ventricle. Okay, so all I'm doing in my brain is seeing this. I have a screenshot of this heart in my head. There's 3 vessels that dump into the right atrium. We've done 2 of them. Superior vena cava, inferior vena cava. They dump into the right atrium. Blood goes through the tricuspid valve into the right ventricle. Now we got to get that deoxygenated blood out of the right ventricle and into the lungs. So we got to go out through this little semilunar valve and then eventually to the lungs. So from that right ventricle, we're going to go through the pulmonic valve. From that pulmonic valve, we will go into the pulmonary trunk. Okay, all that pulmonary trunk is this little guy right here. Okay, here's my right ventricle. Blood's going to go to the pulmonary trunk, and then it will branch, and it will go to my left lung and to my right lung. So this pulmonary trunk is a common ground. It is a common area before we split off and go to the right lung and the left lung, before we split off and become pulmonary arteries. Okay, how do I know it's a pulmonary artery? Pulmonary means lung. And artery means that we are going away from the heart. I've got to get that blood out of this right ventricle and away to my lungs. I got to go through an artery to get to the lungs, and that is done by the right and left pulmonary arteries. Still deoxygenated. We haven't picked up oxygen yet because we haven't gone anywhere. All we've done is go through this right atrium, through the tricuspid valve, right ventricle, pulmonic valve, into the pulmonary trunk, then to the right and left, I should say that backwards, right and left pulmonary arteries. Okay, once we get away from the heart, we are carrying blood to the lungs, we get to change colors, okay, because we've gone away to the lungs to pick up oxygen. So we are going to oxygenate in the lungs. Therefore, half of the word is blue, the other half is red. And yes, that's how I like it, because we read it this way. We go from deoxygenated to oxygenated. Okay. Pick up that oxygen snack in the lungs. Now we've got to get back to the heart. How do I get blood towards the heart? It's going to be a vein. If I'm coming from the lungs, my word root for lung is pulmon. So I'm going to carry blood back to the heart by the pulmonary veins. Okay, right and left pulmonary veins. Why do I have a right and left one? Well, because I have a right and left lung. Why do I have a right and left pulmonary artery? Because I've got to carry blood away to the right lung and away to the left lung. Same thing's true down here. I'm going to bring that blood back towards the heart that is now oxygenated through the pulmonary veins, and I'm going to dump that blood right into the left atrium. From the left atrium, we're going to go through the bicuspid valve, and into the left ventricle. Okay, we're going to leave the left ventricle. We're going to get blood away from the heart again. We're going to go through our next semilunar valve. That's going to be called our aortic valve, to a massive blood vessel in your body called the aorta. Okay, and that aorta is the biggest artery in your body. Okay, it has a diameter of about your thumb. It's like a garden hose that sits in your chest, arches around the top of the heart, down your belly, and then it splits when it gets to your hips. It's responsible for carrying all oxygenated blood away from the heart to your entire body. A pretty important job. That aorta not only has to split off and provide oxygenated blood to your body, but it also has to feed the heart itself. And not only are we feeding all of the other organs, The aorta is going to go feed the brain, feed the stomach, intestines, muscles, yada, yada. Okay? That aorta has to feed the heart muscle itself. It has to say, here you go, heart muscle. You need oxygen too, because you have to contract and you have to have ATP and you have to have nourishment. And so that aorta has to supply not only the body, but included in that is the actual heart itself. We're going to branch kind of up this middle section here in just a second, but I'm going to branch my aorta up to 2 areas of the body that will feed back into the inferior and superior vena cava. Okay, so I'm going to draw myself a little line. And that aorta is going to send oxygenated blood to 2 different, how do I want to do this? 2 different parts of your body, depending on, there we go, depending on whether we are above the heart or below the heart. So we're going to use the stomach as one of the examples. And that stomach is going to use oxygen to digest. So the blood that is the oxygenated blood that's coming from the aorta is going to go to the stomach. The stomach's going to use it up and become deoxygenated blood. That stomach is below the heart. Therefore, it drains into the underside of the heart through the inferior vena cava. The same thing is true for any organ that is above your heart. We will use the brain as an example. The brain will use that oxygenated blood. It will become deoxygenated and it will drain back to the superior vena cava. Everything superior to the heart funnels back to the superior vena cava, the vein that drops in from the front, and not from the front, from the top. Everything from below the heart drains back up that inferior vena cava and goes into the right atrium as well. Okay, so this could be any organ. This doesn't just have to be the stomach. It could be intestines, liver, spleen, bladder, kidneys. Okay, this could be anything above the heart. The same thing would be true there. Okay, so now let's talk about what the aorta is going to do for the actual heart muscle in this section right here. So that heart muscle has to have its own set of oxygenated blood. And it is going to be delivered to that heart muscle by an artery. So the aorta is carrying oxygenated blood away from the heart, and it is going to carry it to more arteries called the right and left coronary arteries. Okay, C-O-R-O-N-A-R-Y. I know that kind of got smushed together. Okay, the right and left coronary arteries. And those arteries are going to deliver oxygenated blood to the heart. Now, I don't want to just write heart right here because there's a lot to the heart. What is specifically bringing that oxygenated blood to is the muscle of the heart. And so the muscle of the heart, remember from yesterday, is the myocardium. And that myocardium will use that oxygenated blood. It'll say, thank you, I will use this oxygen, I will continue to make my ATP, I will continue to contract, I really appreciate it. Then it's got to get that deoxygenated blood back to itself. It's all this kind of inner circulatory process that happens within the heart and on the heart muscle. And all that deoxygenated blood is going to drain through right and left cardiac veins. And that right and left cardiac vein drains, oh, I forgot my left. Right and left cardiac veins will drain all deoxygenated blood back to a common spot on the back side of your heart called your coronary sinus. Oh, man. How did I know I was going to mess up, y'all? Okay. Pretend like this little line is not there. I don't think I have any white out in here. That coronary sinus will drain back to the right atrium along with the, God, makes me so mad when I mess up, y'all. Okay, pretend like it looks like that. Okay, drain back to the right atrium with the superior and the inferior vena cava. Okay, so let me do that again since I had a little boo-boo. Okay, aorta says we're going to deliver oxygenated blood to the body, but we're also going to deliver oxygenated blood to the heart. And these vessels that supply the myocardium are what you see on the surface of the heart. These are the vessels that will get clogged if somebody needs a stent put in or if somebody needs a cardiac bypass. Those arteries, these coronary arteries, are the ones that can cause a heart attack and problems with cardiovascular disease. The aorta gives those arteries the oxygenated blood. Then the myocardium says, I'll take that oxygen and use it. Therefore, it becomes deoxygenated blood. All of that deoxygenated blood drains back to this common spot on the back of your heart called the coronary sinus. And all the cardiac veins join in at this coronary sinus, and that coronary sinus drops right into the right atrium with your superior and inferior vena cava so that we can go to the lungs and pick up oxygen again. Now, I like teaching it like this, but it also makes you think that the right side of the heart does its job, the left side of the heart does its job. These are happening simultaneously. Everything that's on the right and where we're going is happening at the same time as what's on the left and where we're going. So this pathway is two-sided, okay? It is not that we start here and then we end up there, and it does not stop, or one side of the heart does not work while the other is taking a little rest. Okay, so this is the pathway of circulation. I have put, I think there's two little, Sporkle quizzes or little web simulations that I have found to help you practice this. This is just one of those things that you kind of have to commit to memory. And we will do this again once you get your diagrams and can actually see these structures on the heart. But you never really deviate from this. This is the order that it has to go in, or the heart would not function properly. So anyway, practice with those little quizzes. And if you have questions, give me a shout. Sorry for the little boo-boo right there. I think I was just getting ahead of myself. And if I think of any other assignments to put on Google Classroom, then I will. But for right now, just focus on those two quizzes. And I think that's all. Be looking for the present in the mail because the packages should be arriving soon. So fingers crossed we'll have those by Thursday. All right. Have a good day.